Now, when we look at problem number two just ups the combo here of not only doing radicals but also exponents at the same time. And so you see this key take note concept here of a rational exponent. If we turn back the clock, I do remember in a previous video me going to all the way back to when we were looking at lesson 6.1. If we go to 6.1 and then the 6.1 notes, you don't have to get these out. I'll flip here and I'll show you. Is that when we looked at the back here, something like this popped up when we looked at some of these problems here. For example, the square root of 16x to the 8th. And we turned out that the answer, if we looked at just the x to the 8th, the square root of x to the 8th was x to the 4th. And the cube root of a to the 6th, if you look at this guy right here, the cube root of a to the 6th turns out to be a squared. The cube root of b to the 9th turned out to be b cubed. And then even over here on the right for c, did you notice that the fourth root of x to the 8th was x squared? And then the 12th root, I'm sorry, the fourth root of y to the 12th. We were sensing a pattern here. Notice that the solution, the exponent for our solution was actually the quotient of the exponent and the, what do they call that, the index of the radical. Okay, the quotient, meaning the answer to a division problem of the exponent, which is this, for example, down here, look at b in blue. 12 divided by 3 gives us 4. 15 divided by 3 gives us 5. 16 divided by 4 gives us 4. 12 divided by 4. 4 divided by 2. See how these ones would be square roots? So when it comes to square roots, we're actually dividing that exponent by 2. Okay? So that's pretty much what's at play right here, and you notice we kind of wrote that down right here. See that right down there in blue by the star? Notice the pattern about the nth root of a to the m. It's actually equal to a raised to the m divided by nth root. Okay? That's exactly, well, hopefully, exactly what we're seeing right here. It might be a mix up with the m and the n's though. Okay? So if we are taking an nth root, we already knew this, right? Let me highlight it. I'm saying this and that, but I'm not pointing and instructing here, so let me do a better job of that. So we already have established this concept through problem number 1, right? Is that if we take a fraction, 1 over n, it's the same as the nth root. Well, what if there was a number besides 1 on top? What if there was an m on top, a 2, a 3, a 4, a 5, a 6? Pretty much all you're really doing with that number that's right there is you're just taking that base and raising that exponent. Now, the only thing I also want to point out here is that the difference between these two expressions is negligible, meaning they mean the exact same thing. Whichever preference you choose to write it is totally up to you. They mean the exact same thing. It's essentially like somebody saying, I'd like you to take, say, 5 and multiply it by 2 and then divide it by 3, versus somebody saying, I'd like you to take 5 and then say, let's divide it, multiply it by 3. Is that what I want to do? No, multiply it and divide it by 2, and then multiply it by 3. I don't actually think you get the same answer there, so kind of forget everything I just said about that. Maybe it's the pills talking, and maybe I should probably have picked a better time to do this, but let me just go back to this and saying this right here. I probably could think of a better analogy of why it doesn't really matter which way you write it here. But it really doesn't. You can either put the exponent underneath the root, or you can put the root in parentheses and put the exponent outside. It really doesn't matter. What you need to be aware of is that be prepared to read either one and know that they mean the same thing. That's the real important part. Okay? Now, if you notice on this problem right here, do you notice I've graded these ones out? We are going to take a little bit off your plate here. So if you have not at this point already, can you cross off that one that has a negative exponent on it? We are not going to look at those. Okay, so let's look at problem A. Pretty much all this objective is getting you to convert a rational exponent into a radical expression. Okay, so if we have x and then we have 3 to the 7th, I guess I usually come up with, look at the answer right here. X to the 3/7 is the same as the 7th root of x to the 3rd, or the 7th root of x raised to the 3rd power. Remember, this is exactly what I'm talking about right here. There is no one right answer. I don't care which way you write one of these two. Personally, most of the time I see more students write it like this. I don't know why I think it's just because they're just lazy. They don't want to write the parentheses. I'm with you too. I don't feel like writing the parentheses. Let me just give you a nice little tip, because usually what happens here is students usually get these two mixed up and they aren't quite sure where to put them. Let me just put it to you this way. What did we call this 7 that's in this kangaroo pouch here, if you will, of this radical? Didn't we call this a root? Right? And now Mr. Cook is going to use a biology or an ecology example here. If I am going to make a beautiful looking tree, look at this tree. Woo 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 tree. And then we have the ground. Let me ask you a question. And it's not a trick question. Where are the roots? Aren't the roots to this tree all underground? Yes, the roots all go underground. Okay? So these are where the roots live. This is a perfectly great picture. I hope art teachers share this with your art teachers and show you how awesome of an artiste Mr. Cook actually is. And so right there, there's the ground. There's the ground. There's the ground. I'll make it red. Okay? Think of that as being the fraction bar. So like this right here. There's the ground, there's the ground, there's the ground, there's the ground. So the roots are underground, right? So when you see that 7, which is the root, that's the one that's always underground, so you always put that in the root spot. Hey, does that analogy help? I hope it does. Okay? So the roots are always underground, so when you're looking at a fraction, you always put that in the denominator, and then you know where to put that root right there. Okay? And I've already grayed out all the stuff with the negative exponent there. It's still there. You can either cross it off. The only reason why we're not doing that is because that would involve a little bit of a concept known as rationalizing a denominator. I'm going to save that for your trig class and your functions class. Okay, so let's look at example B. Looks like they give us 2 of them this time. Do yourself a favor when you look at these problems, especially this first one. Isn't it saying the square root of a to the 5th? Do yourself a favor and put a 2 right there. Okay? Just that way you remember that roots are underground, and when I want to write this now in exponential form, now that 2, the root goes underground, so I have to put that in the denominator of my fraction, and then 5 is in the numerator. So that should be my correct answer, just like that right there. How's that look? Pretty good, right? And then if I'm looking at the other one, right over here, see where the root is? The root, it's the 5th root. Put that underground when you write your fraction, so it's actually b raised to the 3/5 power. Okay? And so, if we were to take a look at these got it problems here, do you notice I've already grayed out that first negative exponent one? So if you have not done so already, get that one crossed off. We're not going to worry about that one. So let's look at part A. What they want you to do is take that w raised to the 0.2 power, and let's rewrite that in radical form. Okay? In other words, what they're asking you to do is to take this guy right here and rewrite it as a blank root of w to a certain power. It's your job to figure out what go in those 2 boxes. Make sense? Great. Okay? So that's your first job. Now down here, if you look at part B, now they give you the radicals, and what they want you to do is to rewrite these guys as x raised to a fraction with a number there and a number there. Do that for both of those 2 cases, all right? So we'll pause the video at this point, and then let's go over those answers, okay? This is what usually happens when Mr. Cook pauses it. He usually hums a little song. That was a ladybug picnic. All right. Hey, so now that everyone is back, let's go ahead and go over these answers here. So, w to the 0.2. Maybe it might be a little bit better if we rewrote that as a fraction. Wouldn't w to the 2/10 be no different as w to the 1/5? You might write 2 out of 10, but remember, let's reduce that fraction. Now, if I'm going to write that as a radical, remember the root is underground. So what number is underground here? It's the 5, right? So that means I need a 5th root of w. And do you notice something that's missing here? It's that little 1. So yeah, we didn't really need that 1 right there. So the 5th root of w is all that we really needed. Okay, let's look at b. The 4th root of x to the 3rd. So since the 4th root of x to the 3rd is what's being asked here, the root, the 4, needs to be underground. So the fraction that we actually need should be one where 4 is in the denominator, right? So x to the 3/4. Do you see what number? It shouldn't matter whether there's parentheses or not. Do you see where the root is? It's the 5th root, so 5 should be in the denominator there, right? There we go. And so that's what you will have to do. In fact, that is one thing that I know you guys are going to be expected to do as a short answer problem on your test, is I want to see you be able to do that. Can you convert a radical expression into a rational, into a rational expression using a rational exponent, and vice versa, going the other way around? Because standardized tests, they love to ask you that question because it's very quick. It's very easy to see whether or not you know it or you don't know it. Okay, let's move on to the next kind of problem on this lesson.